Good evening. In this video, I would like to show how to find out if you have some problems with data units in time domain electromagnetic data file, how to easy check it in software. Plus, we will see far field zone and discuss it. So I have some file. It contains three components. For 1 GB can exploit only Z components. Other components contains too much noise and 2D and 3D effects, so it's bad for quality. So first sign something wrong with the data is the level of apparent resistivity. If it's much lower or much higher than we expected, this is a problem. Also, our sounding curves can be inverted normally. Let's check. This is some problem with data units. Another thing possible is geometry of transmitter or receiver, but here everything is all right. Personally, I don't like such setup, but we have what we have. Okay, so let's check a file of data, and it's created by Max. I guess here is a problem is units. It's not nanotesla, it's picotesla. And in case I open the data with another data units, it looks correct, and it can be normally inverted. Of course, not so well, but we have this kind of array with massive far field zone in early times. We can see it here. So, for example, here it's quite far from the loop. Intermediate and far field zone takes more than half our orbit for this average level of resistivity. So it's not good. Why it's not good? We can calculate such data, but this data can normally connect to resistivity to challenge. So we will have very rough result for near surface, approximately till 100 meters. See nothing. So this is first trick. Second trick, we can calculate true apparent resistivity and see if true apparent resistivity couldn't give us normal results, and it's very different from later time formula. That's mean some problem with units, or this is not correct setup for this challenge. Let's check. Well, this is pretty different. This means that we work far field zone. at least since here. So right intermediate. So you can see that draw apparent resistivity gives straight line of space. Okay, it can be inverted, no problem. The problem is there is no good connection to resistivity. For example, here this result. Okay, and now I'll try to open file again with nano Tesla units. Try to code. Oh, no roots. This means there's two options. First, units incorrect because we can solve it's only for two last points and it has a crazy, very low resistivity values, or it's all wrongly set up. This is all fire field zone. So this is two tricks you can use, and also here is some options for correction data on import. For example, here is factor for import. It's all data will be multiplied by this factor, or you can use receiver multiplier to check the level, check if everything all right with unit and find factor. Well, thank you very much. Bye bye.